Hi guys, we're back, and this time we're going to talk about what's called a disturbance regime. So the pattern with which we would expect a disturbance to influence an ecosystem. So let's open our slides here. Okay, so disturbances are or can be influenced by many different characteristics. And so we mentioned these when we first started talking about a disturbance, but just really quickly, I'll list them. And again, that's size, frequency, severity, the spatial arrangement of the disturbance, and then also I mentioned seasonality has an impact as well. So I want to kind of talk about those different kinds of patterns that might characterize the way that a disturbance affects an ecosystem. So first, patch size or size of the disturbance is just how large it is. So sometimes we might have a disturbance where maybe there's some sort of fungus or root rot that's growing on the tree that's causing certain overstory trees to die, and it opens up little gaps in the canopy. So that's what you can see on the left, which is going to be really different than if we have some sort of huge bark beetle infestation or a massive high severity wildfire that's wiping out massive areas, hundreds of thousands of acres of forest all at the same time. So it's not surprising to us to imagine that the ecosystem is going to regenerate really differently when we have a disturbance that opens up really small gaps rather than huge gaps all at once. And then I mentioned when we talked about this before that we have been having some pretty severe problems with bark beetle infestations in the Western United States and Canada over the last couple decades. And this is thought to be tied to the fact that we are experiencing warmer winter temperatures. So in the past, when we had colder winter temperatures, the cold temperatures would cause more beetle mortality over the winter. And now that there's less beetle mortality over the winter, the populations are able to kind of maintain these high levels throughout the winter, and then they can just take off in the spring and repopulate and have lots of babies very quickly, as beetles are able to do, and they've really created some pretty devastating problems. There's also thought that in some cases, the bark beetles are able to have more generations of babies throughout the longer summer season, again, because what used to be a longer, colder, more severe winter has not been happening in especially places like Canada over the last like 20, 30 years. So they're having big problems with this in the Rocky Mountains and places like Colorado. We've had some problems with this in the Central and Southern Sierra that have contributed to things like the creek fire that was burning this summer in 2020. And they've had massive problems with this in British Columbia and Alberta. So, for example, there's over 16 million hectares, which is about 35 million acres of dead standing trees that have been killed over the last 20 years in Canada. And this is about the size of the entire Sierra Nevada range. So if you can imagine that every single tree in the Sierra Nevada died over the last 20 years, that's what they're dealing with in British Columbia and Alberta. So it's just astounding. This is a picture not of fall foliage over here, but of dead trees. And then here's a map from 2012. So this is a little out of date, but showing where all this bark beetle mortality has occurred. So you can imagine when this kind of bark beetle mortality happens over such a large scale, then the kind of microclimate that's left behind and the amount of seed bank or the ability for seeds to blow in from nearby areas is going to be really different than when the patch sizes are smaller. Okay, another important thing to understand is how frequent a disturbance occurs. So how often the disruption happens and with what period of time. So, is this something that we would expect to pop up on the landscape every 15 years, every 20 years, every 100 years or 200 years? And locally, we have had a lot of interest in measuring fire frequency. So we know that the system of fires in California right now is really out of control. We don't think it has any match to what was going on in kind of pre-European times in California. And one of the reasons that we know that is because we can look at the tree ring record, and we've talked about the fact before that each of these rings with the light early growth and then the dark late growth represents the spring and summer growth throughout the year. So that represents one annual ring. And then what we didn't mention at the time is you can see when fires have burnt across the wood, they make these little scars called fire scars. Sometimes they're also called cat faces. And so in both the examples on the left and then in the middle here, you can start to see where the fire scars are located, and then you can count the number of rings in between the fire scars, and so you can have a sense of how common fire used to be. And then you can see, starting around the early 1900s, 1910, when we developed this big firefighting infrastructure in order to protect resources and protect communities, fire started to disappear from the landscape, and so has become much less frequent on the landscape. So it might seem like we're having way more fires than before, but that's actually not true. We are actually still burning quite a bit less area in California today than we were burning 100 years ago. It's just that the fires that do burn get really big and really severe and really scary. So that's different, but actually the frequency with which fires are occurring and the total area of California that's burning is still quite a bit lower, like 4 or 5 times less than we saw over 100 years ago. Anyway, the reason that we know this is because we can look at this tree ring record, and we'll do an activity later on in the semester where we look at this. Okay, so what we do know is that there tends to be inverse relationships, meaning as one thing goes up, the other thing goes down. So there's inverse relationships between the size of a disturbance and the frequency of a disturbance. So as the frequency goes up, if it's something that's coming into a landscape and happening repeatedly all the time, then it's probably not going to be able to happen on such a large scale. So for instance, fires that were burning in California 100 or 200 years ago were happening very frequently in areas around Quincy. We think that was around every area around Quincy on average was burnt between once every 8 to 15 years, so very frequent. And then as a result of that, there wasn't a lot of buildup of fuel on the ground. And so the fires that did occur would be very patchy, they would be small, and they wouldn't be these severe mega fires, 300,000 acre, million acre fires that unfortunately we're seeing today. There is also an inverse relationship between the frequency of a fire, or not just a fire, but any kind of disturbance, and the severity of a disturbance. We haven't really gotten a lot into severity yet, but remember that's the amount of the overstory vegetation that gets killed. So again, we used to have a lot of frequent, smaller sized fires in the Sierra mixed conifer forest and in these ponderosa pine forests. And as a result, there wasn't a lot of fuel on the ground, so trees died. But a lot of the larger, more mature trees were able to survive because there wasn't as many ladder fuels and there wasn't as much surface fuel on the ground that allow the overstory to catch on fire. However, that is not true of all ecosystems. The Sierra mixed conifer ecosystem in California is adapted to low severity, high frequency fire. But there are other forest ecosystems that are not adapted to that kind of climate and that kind of disturbance regime. So for instance, forests in the Rocky Mountains, both up in Canada and parts of like Colorado and Wyoming, and then farther north in places like Alaska and black spruce forests in Alaska and these lodgepole pine forests in the Rockies, they are adapted to lower frequency, larger size, and higher severity disturbances. So these big bark beetle infestations, not on the scale that we've been seeing recently, but these kinds of things would have occurred, or more high severity fire, larger scale fire would have occurred in these places in the past, and we can see that from the tree ring record. So many of the species that live in these kinds of ecosystems perhaps have like serotinous cones. They just sit around and wait for a higher severity, more infrequent, larger scale fire to occur. And then after that, a lot of pine cones, these serotinous pine cones, will release their seeds, and then a new crop of forests will regenerate and grow for another 100 years or so until another high severity event comes along, large scale event comes along, and then the ecosystem will start over. So that is a natural cycle in certain places. It just doesn't happen to be the natural cycle that occurred in California and in the Sierra, or most parts of California and in the Sierra in the past. Okay, we also know that there's a relationship between overall diversity on the landscape and the frequency of disturbances. So when we have very low disturbance, we know that it's not opening up patches on the landscape, and we talked about last time that that is actually going to lead to overall lower diversity in our ecosystems. And then on the other hand, if the disturbances are happening so frequently over and over and over and over again, and the ecosystems are just really getting hammered and having a hard time moving beyond the pioneer species, then that can actually lead to low diversity as well. So in this particular graph here, we have low frequency, high frequency, and then we have species diversity. And we can see there's kind of a happy medium where it's kind of the Goldilocks effect. When we don't have too many disturbances, but we don't have too few disturbances, that's usually going to be a happy medium that's going to give us the overall best ecosystem and species diversity. Okay, severity is something I've talked about a few times already, but the severity, again, is kind of like how much of the overstory vegetation is killed. And of course, this is going to be different like in a grassland compared to a forest. But high severity fires, there's a high percentage of the dominant vegetation that's killed. So again, a lot of these big mega fires that are burning up lots of dense forests in California this summer are high severity. They may burn some areas with lower severity or more moderate severity, and then have big runs of high severity. And that's something that would have happened with this bear fire, this North Complex fire. But we know that traditionally the low severity fires that burned and maybe killed certain overstory trees, but mostly kind of burned through the understory and then killed off some of the smaller trees, regenerating trees and shrubs in the understory. That would have been a more typical fire regime for our area. And so we have made efforts to increase the amount of prescribed fire, and we're going to talk more about fire in a couple of weeks here, but we're trying to kind of add more prescribed fire back to the landscape, and then also manage more wildfire. So when wildfire occurs, we are not always able, and we may not want to put it out right away if the climate conditions are okay, and if it's not really adding a lot of risk to a nearby community, we may want to let that fire continue to burn through the understory to leave a more resilient forest behind. There's a lot of complications with prescribed burning that make it difficult for us to really do this at scale, and we're going to talk more about that in the next couple weeks. But these are differences between high severity fire and low severity fire. So there's kind of a famous case in 1988. There was a massive fire in Yellowstone National Park. 80% of the park burned down with high severity. And so you can imagine if this kind of thing happened in some place like Yosemite today, people would be really upset. And there was a lot of concern of like, what do we do? How do we try to regenerate the park? But lodgepole pine, which is the dominant species that grows in most of the forest in the Yellowstone area, is adapted to these stand replacing or these higher severity more infrequent, larger sized fires that I mentioned a couple slides ago. They have at least partially serotinous cones, so they can have some regeneration without a fire, but they regenerate very aggressively and very well after fire. And so you can see that the landscape went from looking like this on the bottom left, which is of course not a very attractive or diverse landscape, to looking like something like this, which is just naturally regenerated forest. Nobody came and planted seedlings in after only a short amount of time. I think this is a 10-year later picture. So obviously the ecosystem has the ability to regenerate well after disturbance that it is adapted to. And in this case, that is a high severity fire. Okay, so another one of the characteristics that we mentioned is the spatial arrangement of the disturbance. So not just how big it is, but how it's spread out. So in this case, you can see different kinds of cutting patterns for logging on the landscape. And you can imagine these kind of patches that are being opened up on the landscape, little clear cuts. Maybe these are like 20-acre openings. And then you can imagine how it might be different if the same total amount of area and same total amount of trees was cut, but it was done in a more patchy way that left little islands, little like wildlife nooks where birds could nest, where different kinds of prey species could hide out, where the trees that are left behind in these little patches might be able to shade and create some different microclimate in the patches around them. And so it's not just the total size that makes a big difference, but it's the spatial arrangement of the disturbance that can have an impact on the regeneration and disturbance of the ecosystem as well. Okay, that is a good place to stop.